Hello, this is Mr. Stansbury. I'm going to take you through the notes on graphs of quadratic functions. At the end of this, you should be able to say, I can sketch quadratic functions by finding the axes intercepts and finding the value of the x squared term. Okay? So really it's just one example here. Actually, example 8, 9, and 10, we put them all in the same spot here just so we can kind of compare them all. Okay? So sketch the graphs by considering the value of A and the axes intercepts. Okay, so the value of A, what they're talking about there is you get y equals ax squared plus bx plus c. And this is the A, the B, and the C for like quadratic functions. Okay, so it says consider the value of A. So right now this A here is, if it's x squared, that means the value of A is 1. So A equals 1. Okay? So since A equals 1 from our previous section, we know it's going to be like a smiley face here. It's positive 1. Okay? Now the what we want to also do is says find the axes intercepts. So let's say the y-intercept is that's when x equals 0, right? So if you put in 0 for x here, that's 0, that's 0. Guess what? Our y-intercept is -8. So we know that this thing's going to cross through right here at -8. Our x-intercepts, that's when y equals 0, right? So if we plug in 0 for this y over here, we go 0 equals x squared plus 2x minus 8. So what we're going to want to do here is we're going to want to factor this thing out. Factors of 8, which are 1 and 8, or 2 and 4. We've got to find the factors of 8 that have a difference of 2. 2 and 4 have a difference of 2. So we got x and x, 2 and 4. We know that this sign in the middle here is always going to go with the bigger of the two factors, so it's plus 4 here. And we know that the factors have to multiply together to get a negative, so a positive times a negative will work here. So what makes this equal to 0? 2, so x is going to equal 2. And what makes this equal to 0? -4 plus 4 gives us 0. So those are our x-intercepts, equal 2 and -4. So at positive 2 is an x-intercept, and at -4 is an x-intercept. Okay? Since we know that this is positive, we know that this thing is going to open up. It's going to be, if it's positive, it's a smiley face. If it's negative, it's going to be a frowny face. Okay, but we know this is positive, so it's going to open up. Okay, so it's going to look something like this. We know that these are two x-intercepts, so that means, let's see, I want to find that total distance there is 6, so that means halfway in between. Somewhere along this line here is going to be where the vertex is. So I'm just going to kind of guesstimate it to be about right there. And away we go. We can draw this, sketch this graph in. And since it's actually 1, we know that from the vertex to get to the next one, when you take 1 squared, you get 1 times 1 gives you 1. So we know that for sure that's actually the vertex right there. Okay, so that is this. We're sketching the graph by considering the value of A, it being positive, and also positive 1, and then also finding the axes intercepts. Okay, let's try that again on this one. Let's see, the value of A is, if we were to multiply this all out, we'd have x times x, this would be x squared, and then you multiply that all by -2. So our A value in here is -2. So that means we know that this is going to be a frowny face, right? And it's also going to be a little bit more narrow because of the 2. Okay? Now, to find the, let's say the y-intercept, we know that x equals 0. So what we're going to do here is we've got -2 times 0 minus 1 times 0 plus 3. Right? So that's -2, that's -1, and that's positive 3. So that's 2 times 3 gives us 6 for the y-intercept. So we know that the y crosses the y up here. And then for the X-intercepts, we know that so X-intercept, we know that the y has to equal 0. So we get 0 equals negative, let's do negative 2 times x minus 1 times x plus 3. Okay, now the nice part about this is that they've already factored it for us. So the negative 2 doesn't really do anything for us except for tell us that it's upside down, and that's kind of skinnier than normal. We want to say what minus 1 gives us 0, and that's when x is 1. Okay, so x is going to equal 1, and we also know that negative 3 plus 3 also gives us 0. So our two x-intercepts are at 1 and at negative 3. So the distance from here to here is 4. Halfway in between means that this here is the axis of symmetry. So it's going to be somewhere up there. So it's going to come down like this. Since this A here is a negative 2, that means to go from the vertex to this point here, we're going to go down 2 and over 1 instead of just down 1 and over 1. So that means to get back up to it, we would go up 2 over 1. There's going to be our vertex right there. And then that one there, because it's mirror image. Missed that dot. Ooh, that one was really bad. It's kind of hard to draw decent lines on this tablet. There we go. Close enough. Okay, so that's what that one's going to look like. Okay? Before we do this last one, let's take a quick comedy break to give our minds a little break here. All right. Last one, C, y equals 1/2 x plus 3 squared. So our A value is 1/2. It's positive, so it's going to be a smiley face, but it's going to be a little bit, it's going to get squished vertically, so it's going to be a little bit wider than normal. Okay, so if we are looking for the y-intercept, again, we know that the x equals 0, so it's going to be 1/2 of 0 plus 3 squared. 0, so 3 squared is 9. Half of 9 is 4.5. So the y-intercept's up here at 4.5. Okay, and then for the x-intercept, we get that we're going to set this equal to 0. So we get 0 equals 1/2 of x plus 3 squared. So again, we want this to equal 0. So this is going to equal 0 when x is, the 1/2 doesn't mean much to us. Negative 3 plus 3 gives us 0. And now here's the interesting part about this. Since it's squared, it's negative 3 and negative 3. So what we're going to do is we know we have an intercept at negative 3. So what's going to happen is this is actually going to come down here and just bounce at negative 3 because that's the only x-intercept. If it were, if this were to go below, we'd have 2 x-intercepts. If it was above, we'd have no x-intercepts. If you get exactly one x-intercept, that means it comes down and just bounces off of that point right there. So these are really the only 2 points that we get, but we know that this is the vertex. So then we can go over 3 more and up to that there. Because this is our vertex. So that means that's our axis of symmetry right there. So then we just sketch like this, and away we go. Officially, since this is 1/2 and we know that's the vertex, we should go up 1/2 and over 1. So there'd be a point right there, up 1/2 and over 1, and there's another point right there as well. Okay, so that's how you graph quadratic functions by using the A value and the axes intercepts. Okay, if you have any further questions, please feel free to ask. Thanks.